Lesson 7.1 was on adding polynomials. 7.2 and 7.3 are about multiplying polynomials. The difference between 7.2 and 7.3 is 7.3 includes these special products, but the special products can be handled exactly the same way as our normal multiplying. So we're going to lump these two lessons together because we can use the same strategy for both. So we only really have one thing to learn. Now, this is what you know how to do, which is the distributive property. This isn't going to be our typical strategy because we're going to come up with a graphic organizer that makes this work a little bit smoother. So say we have these two parentheses multiplied together. The distributive property says this whole parentheses would get distributed because it's multiplied in front of the second one. So I would say x times x plus 2 in parentheses. Plus 5 times x plus 2 in parentheses. So that's just the distributive property. Then we would do the distributive property again, but this time it looks more normal. X times x, multiply something by itself, that's when we use exponents. So x times x is x squared. X times 2 is 2x. 5 times x is 5x. 5 times 2 is 10. And then we would combine like terms when we see an opportunity to. And our answer is going to be x squared plus 7x plus 10. So this up here, where I have two parentheses multiplied together, can come out to one bigger polynomial. Okay, so this is the distributive property. Basically, what I ended up doing is the distributive property twice. If I were to write down what I did, verbalize my ideas, use the distributive property in my first step, and then I use the distributive property again here. Now, there's a graphic organizer that does all of this multiplying as well. And it kind of looks like finding the area of a box. So I'm going to refer to it as a box method. Looks like a Punnett square from biology. So we'll do another problem just like that. So the way to organize this is each binomial or each polynomial multiplied together is the side of a box. So if I have a box, the left side can be my x plus 3. And then I'll make the top of my box x minus 4. Okay, so think of this in terms of like a geometry question. So this side has a length of x plus 3. This chunk of the side has a length of x. This chunk has a length of 3. So totaled up, it's x plus 3. This chunk has a length of x. This chunk has a length of negative 4. I know you can't have a length of negative 4, but just try to work inside the concept a little bit. So if we find the area of all 4 of these sections and add them together at the end, we've found the area of the box. And it's just a graphic organizer for multiplying two polynomials. So I'll do this, and then I'll do it with the distributive property side by side so we can see we get the same result. X times x, we use an exponent to show that, x squared. X times negative 4 for this box is negative 4x. X times 3 is 3x. 3 times negative 4 is negative 12. Now here I'm going to look for any like terms. I've got a 3x and a minus 4x. So when I add all these together, I get x squared. These two combined, 3x plus negative 4x, is negative 1x, so minus 1x, and then minus 12. So I can look for my like terms directly from the box. and get an answer. So real quick, side by side, I'm going to do the distributive property. So I'm going to throw this whole parentheses inside the other parentheses by distributing. X plus 3 plus negative 4x plus 3. I could have done minus 4, but I wanted to make it very clear that negative 4 was going to be distributed. Now I do x distributed in, negative 4 distributed in. X times x is x squared. X times 3 is 3x. Negative 4 times x is negative 4x. Negative 4 times 3 is negative 12. Now look at the pattern. Each of the boxes matches up with each of these terms. I've got an x squared, a positive 3x, a negative 4x, and a negative 12. So then combining like terms, just like I had to do in the box, also gets me x squared minus 1x minus 12. So this is how the box, the Punnett square, the graphic organizer works. What's nice for this is if you have bigger expressions, if we have trinomials or even bigger than that, we just have to make the box a little bit bigger. In my mind, this is a little bit easier to look at. This is a lot of just typical algebra looking steps. This is another way to organize that everything in one term or everything in one expression has to be multiplied by everything in another expression. Here's another example. This time we have a trinomial. So I'm going to do both methods. This is the last time I think I'll do both methods on the examples. I'll start with the box method again. This is my favorite. X and 5 down this side of the box. And across the top of the box, I'm going to need to have 3 terms. So an x squared, a minus 3x, and a minus 2. So each of those terms splits the box into its own section. So since I have a binomial, 2 terms, and a trinomial, 3 terms, I'm going to have 6 total sections of my box. X times x squared is going to be a total of 3 x's multiplied together. So my new exponent is going to be x cubed. Negative 3x times x. Nothing changes the negative 3 here, but now I have 2 x's multiplied together. So that's an exponent of 2. It helps to remember what exponents mean in math. Negative 2 times x is negative 2x. 5 times x squared is just 5x squared. 5 times negative 3x, multiply the numbers, that's negative 15x. 5 times negative 2 is negative 10. Those are all of my products. So now let's circle different like terms. I've got 2x squared terms. I've got 2x terms. And now I'll write out my result. X cubed didn't have any like terms, so it's just x cubed. The x squared terms, 5x squared plus negative 3x squared. 5 minus 3 is 2. 2x squared. Negative 15x plus negative 2x. Those are both negatives, so they'll work together and make negative 17x. And then negative 10 didn't have any like terms, so it's just minus 10. So one more time, I'll back this up by showing the distributive property. Distribute in my whole x plus 5. So I'm going to have x squared times x plus 5. Then I'm going to have negative 3x times x plus 5. Then I'm going to have negative 2 times x plus 5. Now I'll have to do 3 more distributes. Distribute x squared, distribute negative 3x, distribute negative 2. X squared times x is x cubed. Just like that, x cubed. X squared times 5 is 5x squared. Just like this 5x squared. Negative 3x times x is negative 3x squared, just like this, negative 3x squared. Negative 3x times 5 is negative 15x, just like this negative 15x you see in the pattern. Negative 2 times x is minus 2x, right there. Negative 2 times 5 is minus 10, right there. And if you're not convinced yet, let's actually combine like terms and see that we get the same answer. X cubed plus 2x squared, 5 minus 3 is 2, minus 17x, negative 15 and negative 2 work together. So I add them and they make a even further negative number, and then minus 10. Same result, same polynomial. All right, let's do a quick little refresher on degree. What would the degree of this be? Why don't you take a guess for yourself? The single biggest power of any term. So this whole polynomial has a degree of 3. Lead coefficient is the number in front of our biggest degree term. There's nothing there, so we know that it's a 1x cubed, so my lead coefficient is 1. And then classification. This is a 1, 2, 3, 4 term expression. So we have monomial, binomial, trinomial, and anything bigger than 3 is just polynomial. So this one doesn't have one of the special names because it's too big. So just a little refresher on something we did in 7.1. Last thing I'm going to talk through is, do we remember what to do here? You need to know what an exponent does. I know in lesson 6.1 you would have wanted to apply the exponent to each of the inside terms, but let's move away from that mindset a little bit. That wouldn't actually work here. In 6.1, everything inside the parentheses was multiplied together, so that worked. It doesn't actually work here. So this is not x squared plus 3 squared. So we need to get that out of our minds. We want to go back to the original meaning of exponents. Repeated multiplication. The squared means multiply this by itself twice. So this means x plus 3 times x plus 3. Now, based on what we've just done in this lesson, we should know how to handle that. I'm going to draw a box. One side's an x plus a 3. The other side is an x plus a 3. And when the sides are the same, it is a square. Ooh, I wonder why. I wonder why we call this squared instead of to the second power. Sorry, just trying to draw some connections for you. So this is going to be x times x is x squared. X times 3 is 3x. X times 3 is 3x. 3 times 3 is 9. Combine like terms, and we get x squared plus 3x and 3x makes 6x plus 9. So there's my answer. And there's actually a pattern here if we looked at more. Whenever you have something plus something in parentheses squared, the result is always the first thing squared plus 2 times the first thing times the second thing plus the second thing squared. This is its general form. And for a minus b squared, it's very similar. Now it's a squared minus 2ab plus b squared. So this is just a pattern. These aren't necessary to memorize because you can always just handle the problem this way. But it's just interesting, these patterns that show up. They can be shortcuts, but luckily we always have this to fall back on.